Friends, in previous lecture we have seen the theory part of T and L beam. So how to analyze a T beam, how to find out the moment of inertia of T beam, and how to calculate the XU value for T beam. So we have seen the three different cases of T beam. So case number 1 in which the neutral axis depth was less than df. Case number 2 in which the neutral axis depth was greater than df, but the df value is less than 0.43 XU. And third case was XU depth of neutral axis is greater than df as well as df value is greater than 0.43 XU. So three different cases was there. Now in today's lecture we are going to see how to solve the numericals on T and L beam based on the equations which we have developed in previous lecture. Okay, so please keep the notes of previous lecture in front of you so that you can easily understand the today's topic or today's numerical, how to solve this numerical. So let us start with the numerical number 1 of today's lecture. So I will read the numerical for you, please note it down and then we will solve. Okay. So find the moment of resistance mu of a T beam with the following data. Depth of a flange is 120 mm, width of flange is 1100 mm, width of wave is 275 mm, effective depth is 450 mm, AST, total AST is 2700 mm square, FY is 500 Newton per mm square, and concrete grade is M25. So now all the data, dimensions of T beam is given, AST value is given, and grade of concrete and steel is given. We have to find out the value of mu. Now, so first question arises that this beam belongs to which case? Case number 1, case number 2 or case number 3. So we have seen three different cases, and first of all you must identify which case belongs to this type of numerical, means this numerical belongs to which type, which case. जोपर्यंत तुम्हाला केस कळणार नाही, केस नंबर 1 आहे, केस नंबर 2 आहे की केस नंबर 3 आहे, तोपर्यंत तुम्हाला मोमेंट ऑफ रेजिस्टन्स कॅल्क्युलेट करता येणार नाही. सो फर्स्ट ऑफ ऑल यू हॅव टू फाइंड आउट द केस इन विच दिस न्यूमेरिकल, दिस टी बीम belongs. Okay, so first of all write down the given data. So given data is given data, depth of flange is given, it is 120 mm, then width of flange is given, it is 1100 mm, then width of wave is given, it is 275 mm, next is D is given, it is 450 mm, then AST is given, it is 2700 mm, then FY value is given, it is 500, FY value is 500 Newton per mm square, and concrete grade is given, it is 25 Newton. Now all the given data I have listed here. Now what we have to calculate? We have to calculate the moment of resistance. So let us first check in which type of case this numerical fits. Okay. So for that, what you have to do? In previous lecture we have derived different equations for different cases, but we have not learned that how to identify the case of a beam which is given. Okay, so what is first case? Case number 1 is when XU is less than DF, that is case number 1. And what is second case? XU is greater than DF. In third case also XU is greater than DF. Okay, So there is no such method in which you will get in step number 1 only that all numerical belongs to which type of case. So there is no any method so that you can identify detailed case of that particular numerical. But there is one option, there is one method by which we can say that whether the beam or the numerical belongs to case number 1 or case number 2 or 3. म्हणजे एक तर तो केस नंबर 1 मध्ये असेल किंवा 2 किंवा 3 मध्ये असेल. Okay, if you identify if it is in case number 1, then you can solve by using procedure of case number 1 only. Okay, but if it is not in case number 1, then it will be either in case number 2 or in case number 3. So for that you have to use trial and error method. So first you have to assume it is in case number 2. If it is okay, then proceed. Then if it is not okay, calculations are mismatching, then you have to again consider the method, you have to assume that it is in case number 3 and you have to solve. Okay, so if the numerical or the given beam is in XU value is less than df, then it is simple. But if the XU value is greater than df, then it will be little bit laborious work, because you have to use trial and error methods. First you have to assume case 2 and then you have to assume case 3. Okay, so how to identify whether it is in case number 1 or 2 and 3? So for that you have to calculate ASF value. What is ASF? So ASF is area of steel required for compression to be within the flange. Compression to be within the flange means XU value less than df. ASF required for XU value less than df. ही जी स्टीलची अमाउंट आहे, एवढ्या अमाउंट पेक्षा जर कमी स्टील असेल तरच XU is less than df, म्हणजे कॉम्प्रेशन फक्त फ्लॅंज मध्येच आहे, मीन्स XU is less than df. But your given AST value, now this given AST value is 2700. If it is greater than ASF, then XU is greater than df. If this AST value is less than ASF, means XU is less than df. Okay, ASF is the maximum steel required to maintain the value of XU less than df. Case number 1. Okay, so how to calculate this ASF? So it's a simple formula from which we calculate the value of XU. That is 0.36 FCK B into df divided by 0.87 f. Okay, now substitute all the values, we know the values. So 0.36 FCK is 25, B is 275, df is 120, 0.87 into 500. If you calculate this, you will get this value 2731. Now you have to compare this ASF value with AST. Okay, if AST is less than ASF, then XU is less than D. If AST is greater than ASF, then XU is greater than D. It's very simple equation, it's very simple concept. Okay. Now ASF is 2731 and AST is 2700. It means that AST is less than ASF. So XU is less than D. So it belongs to case number 1. So this is our first numerical which belongs to case number 1. So it is simple task for us to solve. Okay. So AST is less than ASL, so definitely XU value is less than DF. Now we will calculate the value of XU and we will calculate the moment of resistance by equations for case number 1. So this is our case number 1. So case number 1 is nothing but you have to solve the beam for using the formula as like we are using formula for the singly reinforced rectangular beam. Okay. So first we will calculate XU value, actual XU value. आता इथे आपल्याला फक्त एवढं कळलं की XU value less than DF आहे, but what is actual XU value you don't know. So we will calculate first. So it's 0.87 Fy into BF. Sorry, 0.87 Fy into ASP divided by 0.36 FCK. And this compression is equal to tension. Therefore, just compression is equal to tension. Rearrange it up and calculate the value of XU. So 0.87 Fy is 500, AST 2700, 0.36, FCK is 25, and BF is 110. If you calculate this value, it is equal to 118.636. So its value of XU. Now compare this with XU limit. Compare this with XU limit. What is XU limit? For Fe 500, what is XU limit? It is 0.460. 0.460. So 0.46 into D. D is effective depth, 450. So its value is 205.2. So actual XU is 118 and XU limit is 205.2. So which type of section it is? Under enforced, over enforced, or balance? XU is less than XU limit, it means it is under enforced section. So section is under enforced. Now just have to calculate the value of moment of resistance, compression or tension into lever arm. So as the section is under enforced, so we will take the tension into lever arm. Okay. If you take compression into lever arm also, but you have to put the value of XU as actual XU value, then also the equation will not change. Okay. So substitute all the values. 0.87 Fy into AST into lever arm D minus 0.42 XU. Substitute all the values. 0.87 Fy is 500. AST is, what is AST? AST is your actual AST is 2700. D is 450 minus 0.42 into substitute actual XU 118. If you calculate this, you will get this as a 470 kilonewton per meter. So calculation for case number 1 is very simple. Calculation for case number 1 is very simple. Just you have to calculate value of ASL, that is one additional step as compared to your single reinforced rectangular section. Otherwise, all other steps remain same. Calculate XU, compare with XU limit, and calculate here. Okay. So this is the first numerical in which the case was case number 1. So now we will try to solve some little bit complicated examples. So I will read the second numerical, just note it down, then we will solve. Find the moment of resistance of T beam with the following data. The data is given. The BF is 1500 mm, BW is 300, D is 600 mm, DF is 100 mm, AST is 4500 mm square, M20 concrete and AP 415 grade steel. Okay. Now we have to find out the MU. All the data is given. Okay. Similar example. We don't know in which case it belongs. We'll follow the same procedure. So I will write the given data first. Again, depth of flange, it is 100 mm. Width of flange, it is 1500 now. Width of vein is 300. Then AST is 4500 mm square. M20 concrete grade, which gives FCK is M20, 20 Newton per meter square, and Fy is 415 Newton to mm square. Okay, all the values are given. Again, we don't know in which case it belongs, from which case it belongs. So first we will find out the case. So again we will calculate ASF value. Steel required, ASF represents steel required for compression to be within the flange, for compression within the flange. Okay. So ASF again 0.36. FCK BF into DF divided by 0.87 FY. 0.36 FCK is now 20, BF is 1500 and DF is 100. 0.87 FY is 415. So if you calculate this, it is 2991. 0.275. So for steel required for compression within the flange is 2991. And if you compare with our reinforcement steel AST, it's 4500. So it is more than this ASF. It means XU is greater than DF. So it may be a case 1, case 2 or case 3. We don't know whether it is case 2 or 3. It may be case 2 or may be case 3. So AST is greater than ASF. Okay? Otherwise, right? AST is greater than ASF. It means XU is greater than DF. So it may be case 2 or case 3. आता याच्यावर एकच क्लियर होते की हे केस नंबर 1 नाही, केस 2 असेल किंवा केस 3 असेल. ओके, सो लेट अस अज्युम दैट इट इज केस 2. ओके, assuming case 2 means what? Case 2 means XU is greater than DF, that is okay, but DF is less than 0.43 XU. DF is less than 0.43 XU. So we are assuming. Now we will calculate value of XU. Again we will equate compression is equal to tension. Compression equal to tension. So compression is, now compression in weight separate and compression in flange separate. We have calculated this in our previous lecture. So calculation in weight, CUW plus CUF is equal to tension. So tension is 0.87 Fy into AC. So CUW and CUF. So what is CUW? Compression in weight. So if it is a T-beam, wave means we are going to consider this part, okay? And flange means the remaining part. Okay, so CUW we calculate as 0.36 FCK BW into XU. Okay, but CUF you have derived this in previous lecture. Now in what is CUF? CUF is 0.446 FCK into 0.446 FCK into BF minus BW into DF. BF minus BW into DF. This is compression in flange. Is equal to 0.87 Fy, that is your total tension. Okay. So now just substitute all the values and try to calculate value of XU. From this we are going to calculate XU. Okay. So substitute all the values and try to calculate XU. So 0.36 FCK is 20, then BW is 300, then XU value we have to calculate. Okay, then 0.446 into FCK is 20 into BF is this 1500, yes, minus BW is 300 into DF is 100. All it is equal to 0.87 Fy into AST. AST is 4500. Okay. In this equation, I have substituted all the values. 0.36 FCK is 20, BW is 300, XU we have to calculate. Then 0.446 FCK is 20, BF is 1500, BW is 300, multiplied by DF is 100, is equal to tension 0.87, Fy is 415, AST is 4500. Now if we calculate this, we will get value of XU. It is 256.60. 253. Okay. From this we know that it is greater than DF. XU is greater than DF. But we have to check whether it is case 2 or case 3. So for case 2, this DF value should be less than 0.43 XU. DF value should be less than 0.43 XU. Now calculate this 0.43 XU. So 0.43 XU. So 0.43 multiplied by XU is 256.63. So if you calculate this 0.43 XU, it is 110.35. So it is 110.35. Now what is your case 2? XU is greater than DF, that is okay. This XU is greater than DF. But DF is less than 0.43 XU. So DF less than 0.43. What is DF? DF is 100. And 0.43 XU is 110. So DF is less than 43 XU. 0.43 XU is 110 and DF is 100, means DF is less than 0.43 XU. So this condition is satisfied. XU is greater than DF, yes. Then DF is less than 0.43 XU, yes. Okay. So this is case number 2. Now this we can conclude that this is case 2. So we can use now case 2 formula for calculation of MU. So for MU calculation, you have to check whether the value of XU limit. XU limit is again 0.48 D now because it is 415 units D. So 0.48 into D is effective depth. Effective depth, whether it is given. Let me check. Yes, depth of beam is also given. It is 600 mm. 600 mm. So XU limit value is 316.9 and our value is 256. So it is less than XU limit. In section is under-enforced. Section is under-enforced. Okay. But as we have to find out the moment of resistance for under-enforced section, we will take compression into overall, but we will put the value of XU as actual XU, not XU limit. Okay. So MU value. So CU W into lever R plus CUF into lever R. We have derived this equation in previous lecture. Okay, substitute all the values. CUW 0.36 FCK BW into XU into bracket D minus 0.42 XU plus this is CUF 0.446 FCK into BF minus BW into DF into bracket D minus DF by 2. Okay. Now substitute all the values. 0.36 FCK is 20, BW is 300, XU actual XU you have to substitute 256, D 256.63. So substitute make decimal points 256.63. Then BF D minus 0.4. So D is 600 minus 0.42. XU is again 256.63. First it is complete. Then second 0.446. FCK is 20. BF is 1500 minus BW 300. DF is 100 into 600 minus 100 by 2. D minus DF by 2. Okay. Now if you calculate this, you will get the value of mu, it is 862.13 kilonewton meter. If you calculate this, you will get the mu value as 862.13 kilonewton meter. Okay. So that's it. In today's lecture will stop here. We have seen two numericals, one from case 1 and second from case number 2. Okay. So this is about TB. Okay. Thank you.